This is half past paper, week 22, higher tier, and this is a calculator paper again this week. We are doing the even numbers to the odd numbers that we did last week. So if you were here last week for week 21, this is the other half of the paper. These are all the topics that we are going to be looking at on this paper, and there are 38 marks. So about half a past paper. Normally these papers are out of 80. Okay, let's get on with it. Okay, question number 2, find the highest common factor of 60 and 84. So the highest common factor is the biggest number that fits into both of those numbers as a factor. There is a method, and we're going to do the prime factorisation of both of those numbers. So we're going to start with 60 at the top here, and we're going to split that up into two numbers that multiply together to make 60. Now these can be any numbers you like. When you get to a prime number, you're going to circle it, and then if it's not a prime number, you're going to carry on. So your prime numbers, remember, are 2, 3, 5, 7, 11, 13, 17, 19, and so on. They're numbers that are only in the 1 times table and their own times table. So 60, I'm going to split that up to be 6 times 10. Why not? Now, neither of those are prime, so I'm going to carry on with both. 6 is 2 times 3, and they're both prime. And 10 is 2 times 5, and they're both prime. There we go. So 60 is 2 times 2 times 3 times 5. With 84, let's make that 42 times 2. 2 is prime. 21 times 2. And then 21 is 3 times 7. So 84 is 2 times 2 times 3 times 7. We're then going to do a Venn diagram for both of those numbers. This circles for 60, this circles for 84. And in the middle, I can put a 2, because they both have a 2. I can put another 2, because they both have another 2. And they both have a 3. So 2, 2, and 3 can go in the middle. I've got a 5 left over out here for 60. And I've got a 7 left over out here for 84. The highest common factor is the part that fits into both. So we want to multiply all of these numbers together in the middle. 2 times 2 times 3, and that is 12. So 12 is the biggest number that is a factor of 60 and 84. Now you might think, well, that's a lot of work for doing that. But that method will always work no matter how big the numbers are. So it's a really good method to know. Okay, for part B, find the lowest common multiple, and we can do this in the exact same way. You can just list 24, then 48, then 72, and so on. And because you've got a calculator, you might find that an easier way to do, and you can just keep going. 96, add another 24 is 120, and then if you go 40, 80, 120, the lowest common multiple is going to be 120. It's the first number in both their times tables. However, let's see how we can use that method at the top again. So 24 is 8 times 3, which is 2 times 4, which is 2 times 2. So 24 is 2 times 2 times 2 times 3. And then let's just do the same with 40. 40 is 8 times 5, 2 times 4, and 2 times 2. So then if I have my Venn diagram, this circles for 24, this circles for 40, and in the middle we can put 2 and 2 and 2 because they all have those 2's. 24 has 3 left over and 40 has 5 left over. So your highest common factor is 8. You would then times that by any numbers left on the outside, so by 3 and by 5, and that is 120. So we get the same answer either way. But it's good to have a method just in case you want it. That is the method seen above. All the numbers in the middle times together, that's the highest common factor. Multiply that by any numbers left on the outside, and that is your lowest common multiple. Or you can just list both numbers, but people tend to go wrong, like be 1 out or 10 out when they do that. So just be really careful if you are going to list the numbers that way. Okay, question number 4. Complete the table of values for y equals x squared minus 2x add 2. Now you do have a calculator for this paper, so you can just type this in your calculator. I'm going to do it both ways. You can use the table of values function in your calculator, which I've done videos on separately, or you can just use the bracket method. Now I really like the bracket method. I think it's quite simple, quite straightforward. So in my calculator, I'm going to type this. But every time there is an x, I'm just going to put brackets. So in my calculator, I'm typing bracket, bracket squared minus 2, bracket, bracket, add 2. And then all I'm going to do is use the left-hand arrow of my calculator. So you've got that top button like that. I'm going to just use this left-hand arrow to go back and put whatever x value I want in the brackets. So bracket, bracket squared minus 2, bracket, bracket, add 2. And then back in those brackets, I'm going to start by putting minus 1 in both of those brackets. Now, if you put minus 1 in both the brackets and you hit equals, it tells you that that is 5. Now, the beauty of this method is now all you need to do is use that left-hand arrow and go back to both of those brackets and just change it to 1 instead of minus 1, because that's the next number that we need to work out. And when we do that, I get 1 as my answer. Now we're just going to go back to both of those brackets and change it to be a 2. And that gives me an answer of 2. And then again, I'm going to go back to both those brackets and change both of the inputs, both of the x's, to be 4. And that gives me an answer of 10. I'm happy with that, okay? So all I was doing there, let's just show you with the 4, is putting the 4 where the x is here and where the x is here. So to get y, you need to do 4 squared minus 2 lots of 4, add 2. And by putting it in brackets, you make sure that any negatives are squared correctly. So 4 squared is 16, take away 8, add 2, and that is indeed 10. So that's how we got that answer there. You're just using this as your rule. And now we've got to draw it. So each of these is a coordinate that we're going to plot on the graph. So minus 2, 10 would be here. Minus 1, 5 is going to be here. 0, 2. 1, 1. 2, 2. 3, 5. And 4, 10. And now you're going to join that up with a nice smooth curve going through all of the points and making sure that it's not pointy at any at the bottom there. It should be a nice smooth curve. So touching that. Oh, yeah, I'm going to redo that like this. And coming back up like that. There we go. And that is a quadratic graph. And we've had to draw it between minus 2 and 4. So there we go. It then says use your graph to find estimates of the solutions to the equation x squared minus 2x add 2 equals 4. Now this is what we've just drawn on the graph. X squared minus 2x add 2 is what we've just drawn. And they would like to know, when does it equal 4? Now to find out when it equals 4, I'm going to draw a line going across at y equals 4. When does y equal 4? When does the graph equal 4? And there's two places. Here is one place it equals 4. And here is another place it equals 4. So for that, I'm looking at those values there, and I'm going to say that that is minus 0.75. And let's go with 2.75 as well. So minus 0.75, or, and you can say and if you want, 2.75. Let's go with that. You might have said 2.7, 2.8, or anywhere in between, or minus 0.7, minus 0.8, or anywhere in between. That's absolutely fine. Okay, question number 6. ABC is a right-angled triangle, and this is immediately giving me Sokotoa vibes. It's a right-angled triangle. We've got an angle involved, and we're finding out a missing side here. So we want BC, which is this one over here. First thing we're going to do for Sokotoa, So, Ka, and Toa, is to label our sides. So always, wherever the right angle is, here, you're going to go over, and that is your hypotenuse. You're then going to stand in the other interesting angle. Over from that is your opposite. And next to that angle, that's the adjacent. So those are your three sides. Now we need to determine what is involved. So the opposite is the thing we're trying to work out. That is definitely involved, or we want that involved in our formula triangle. The adjacent, we know, is 12. So that's quite helpful information. With the hypotenuse, I don't know how long it is. And I don't want to know how long it is. It's not the thing we're trying to work out. So therefore, that's not going to be helpful in my formula triangle. That leaves me with A and O. So hopefully it makes sense if I say we're going to use TOA here. So in TOA, cover up the thing you want to know, which is the opposite, the O, and do the sum that's left behind. Now remember, SO, the S stands for sine of the angle, so sine 56. If I was using Ka, it would be cos 56. But we're using TOA, so that T is tan 56. So T times A is tan 56. Don't forget to shut the angle after the shut the bracket after the angle, times by the adjacent A, which is 12. Typing that in my calculator, tan 56, shut that bracket, multiplied by 12 is 17.79073. And they want that to one decimal place, so I'm going to put 17.8 as my answer. Then we have PQR is a right angled triangle. Work out the size of the angle marked X. Give your answer correct to 1 decimal place. Again, this is SOHCAHTOA, but this time we're finding an angle. This is your hypotenuse, this is your opposite, and this is your adjacent. Now the opposite, I don't know how long it is and I don't want to know how long it is. A and H are going to be involved here, so this is going to be K. Now with your K triangle, with all of the triangles, this bottom left-hand letter is your angle. So here, because I want the angle, if I cover this up, I know that cos of X is the adjacent over the hypotenuse. And because we want that angle, I need to undo that cos. So we're going to say cos to the -1 of 15 over 18. The A, the adjacent, is on the top. The H, the hypotenuse, is on the bottom. So to get that cos to the -1, you're going to press shift and then cos in your calculator. I like to use the fraction button as well, 15 over 18, but you can put 15 divided by 18, that's all fine. And that gives you 33.5573 to 1 decimal place, 33.6 degrees. Oh, there we go, like that. Question number 8. The group frequency table gives information about the time in minutes taken by 50 people to solve a puzzle. So frequency means how many people. So at the minute I know that 5 people took between 0 to 10 minutes to complete the puzzle. 8 people took between 10 and 20 minutes, and so on. And we're being asked to draw a cumulative frequency, or Brian was asked to draw a cumulative frequency table for this information, and this is the table that he's drawn. Now with cumulative frequency, we add it up as we go down. So 0 to 10 is 5, and then 0 to 20 is the 5 and the 8 added together, like that. But what he's done is he has forgotten that he's adding it. So these categories should all be starting from the same point. So if he's added on the 8, he's got 13. But those 13 people go from 0 to 20, not 10 to 20. So each of the categories should begin from 0. So all of the categories should begin at 0. He's added them up. So he's added them together and therefore it should add up. It should be starting from 0, sorry. Okay, question number 10. Louise invests X pounds in better investments for 3 years, and Sadiq invests X pound in County Bank for 3 years. At the end of the 3 years, the value of Louise's investment is £344,605. Work out the value of Sadiq's investment at the end of the 3 years. So we can see from the X and the X that they are investing the same amount. So we're going to start with Louise because we've got her answer, and we're going to work backwards. Now she is invested in this bank. So for Louise, we know that we've got X pounds times by 1.025 to the power of 3, and her investment is £344,605. Now, where have I got this from? Well, if I'm getting 2.5% interest, that's 100% of your money and an extra 2.5% on top. That is 102.5%. And if I want 102.5%, I can multiply by 1.025 because that's what that would be as a decimal. I then need to raise that to the power of the number of years. And because we know it's 3 years, we know that's the power of 3. So working backwards, if I want to know how much money she started with, I'm just going to take 344,605 and divide by 1.025 to the power of 3. So 344,605 divided by 1.025 to the power of 3. And that is 320,000. Always reassuring when you get a nice round number. Feels like you've done something right, doesn't it? 320,000 is X. So now we can look at Sadiq's investment. He invested the same amount of money. So 320,000 was his starting amount. Now he's put it in County Bank. So he gets 2% per year for the first 2 years. So we're going to times by 1.02 because we want 102% for 2 years. And then times that by 1.035, which is 103.5%, for the third year. We get that for every year afterwards, but we know that it's only 3 years in total, and we've already done 2 of the years here already. So therefore, we've got 320,000 times 1.02 squared times 1.035. And that gives me 344,580.48. And because it's money, it was 2 decimal places anyway, but because it's money, I'm going to leave it as 2 decimal places. If it was more decimal places or less, we would want to make sure it had 2 decimal places because it is money. There we go then, £344,580.48. Be aware that sometimes on these questions it says, how much interest did Sadiq earn? You'd then have to subtract the 320,000 away to get your final answer for full marks. Just be really aware of that. But on that one, it didn't. We're all good. Okay, question number 12, and we're expanding 3 brackets. So first thing we're going to do is multiply the first 2 brackets together. If I gave you the question 3 times 4 times 5, you would do 3 times 4, which is 12, and then you could times that by 5, okay? So we're not going to try and do it all at once. We're just going to times 2 of them together and then times it by the 3rd bracket afterwards. You could have done that in a different order, but it's the same. So let's times this out. X minus 2 times 3x add 2. Now I do x times 3x, which is 3x squared, x times 2, which is 2x, minus 2 times 3x, which is minus 6x, and minus 2 times 2, which is minus 4. Collecting together these like terms, I've got 3x squared minus 4x minus 4. I then need to take that and multiply it by the 3rd bracket, 2x add 3. Now I personally would do this by doing 3x squared times this and 3x squared times this, and then minus 4x times this and minus 4x times this, and minus 4 times this and minus 4 times this. However, I know a lot of you find that quite confusing, and in an exam I think it's probably better just to lay it out in a way that you know you're not going to go wrong. So either way, I'm going to do it both. This is another way of doing it where you can just lay it out in a table and we're multiplying these things together. So 3x squared times 2x is 6x cubed, minus 4x times 2x is minus 8x squared, minus 4 times 2x is minus 8x. And then I've got 3x squared times 3, which is 9x squared, minus 4x times 3, which is minus 12x, and minus 4 times 3, which is minus 12. You can then collect the like terms like this. So that gives me 6x cubed, add x squared, because I've just got 1x squared left, minus 20x minus 12. Let me do it the other way then. I'm going to start with the 3x squared. 3x squared times 2x is 6x cubed, and 3x squared times 3 is 9x squared. Moving over to the minus 4x, I'm timesing that by each of the things in the other bracket. So minus 8x squared and then minus 12x. And then moving over to the minus 4, and I've got minus 8x minus 12. These two come together and these two come together, and we're going to get the exact same answer, but just another way of doing it. Okay, so whichever one works better for you, there is nothing wrong with either, and you would get full marks no matter what if you got that answer on the answer line. So there we go, 3 marks for that one. Expanding triple brackets is the topic. Okay, question number 14, and we have circle theorems here by the looks of it. A, B, C and D are 4 points on a circle. SBT is a tangent, and angle ABD is 20 degrees, which is labelled on there for us. The size of angle BAD, so this angle here, and the size of angle BCD, which is this one here, is in the ratio 3 to 1. So this one is 3 parts, let's put 3x, and this one is 1 part, so we can put 1x there. So BAD to BCD. Now what we have there is a cyclic quadrilateral. All 4 corners of our quadrilateral are on the edge of the circle, so we call that a cyclic quadrilateral. And we know that the opposite angles in a cyclic quadrilateral add together to make 180. So whenever you have a cyclic quadrilateral, these 2 angles will always add to make 180, and these 2 will add to make 180. So I know that 3x add x equals 180. So 4x is 180, and if I divide that by 4, I get 45 degrees. Therefore, x is 45, so this one here is 45 degrees, and 3x is 3 lots of 45, which is 135. Ooh, 135, so let's pop that in there. 135 degrees, lovely. We've got to find the size of angle SBA, which is this angle here. That's what we've got to work out. So let's keep going, let's see what else we can get. Now I've got, at the minute, a triangle on its tip on the tangent. When that happens, we can use the alternate segment theorem. So if you have a triangle like this, where all three corners of the triangle are touching the edge of a circle, this angle will always be the same as this one, and this angle will always be the same as this one. And you can see that that's happening here with this triangle. It's really over to one side, but it doesn't matter, we can still do that rule. So therefore I know that this angle here is 135 degrees, because this angle is 135 degrees. And then we can just use angles on a straight line to add that up. So I've got 135, add 20, which is 155, 180, take away 155 is 25 degrees. So that would be my answer for that. Now, it does say give a reason for each stage you're working. So we do need to say everything that we've done. So what have we done? We've used opposite angles in a cyclic quadrilateral, opposite angles in a cyclic quadrilateral, add to 180 degrees. That was the first reason we used. We also used alternate segment theorem, this one. Alternate segment theorem. And we also used angles on a straight line. Oh, straight line, add to 180 degrees. Was that everything we used? I think it was. Opposite angles in a cyclic quadrilateral, and then we said that that was alternate segment theorem, and then we used angles on a straight line, add up to 180 degrees. That's everything. Yeah, there we go. So 4 marks for that one, and we said that our final answer would have been 25 degrees. Very tricky, that one. Circle theorems, so get to know them. They are quite difficult. Okay, question number 16. Use the iteration formula xn plus 1 is the cube root of 10 minus 2xn to find the values of x1, x2, x3. Start with x0 is 2. Now this looks so difficult, but it is just substitution. So get used to this formula. x0 is the first value that you're going to be given, and that's 2. Now x1 is just the next value of x. x2 is the value after that, and x3 is the value after that. And all this xn plus 1 means is to get to the next x. So to get to the next x, you're going to do the cube root of 10, take away 2 lots of the x you're on now, if that makes sense. So xn is the one you're on now, and xn plus 1 just means the next one. So they're telling you to start with 2. So therefore, to get to the next one, x1, you're going to do the cube root of 10, take away 2 lots of 2. And you're going to type that in your calculator. Now, the easiest way to actually do this is to hit 2 in your calculator and hit equals, and then it will be stored as the answer. And then you can just use your answer button moving forward, and it'll always update it. So I'm going to type the cube root of 10 minus 2 lots of my answer. And that will then take the 2 that I already stored and use that. And that gives me 1.817120.593. I really wouldn't round anything. I would use all of the digits. Because I've used the answer, I don't have to type that in again. That is now my new answer. So when I hit equals again, it will update it. So 1.8533184996. And hitting equals again, I get 1.846265,953. There we go. So those are your values for x1, x2 and x3. And I should have written them there, but I'm not going to write them out again. So hopefully you can forgive me for writing them up there. The values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form x cubed add ax add b equals 0, where a and b are integers. Find the value of a and the value of b. So yes, we need to work with this. This is a cubic that has been rearranged, is what they're saying. So we've got the cube root of 10 take away 2x equals x. Fabulous. So all we're going to do now is we're going to rearrange this so that it looks a little bit more like this. So I'm going to start by cubing both sides to get rid of that cube root. x cubed equals 10 minus 2x. I'm then going to add 2x to both sides. And then I'm going to take away 10. So x cubed add 2x minus 10 equals 0. Therefore a is 2 and b is minus 10. Basically take the iteration formula but take the n plus 1 and the n out of it. And then you're just rearranging it until it looks like that. There we go. A is 2, b is minus 10. Fabulous. Question number 18. Here is a graph of y equals sine x from 0 to 360. Using this graph, find estimates of all 4 solutions for when sine of x equals 0.6 between 0 and 720. So we can see that our graph here only goes across to 360. But we know that the sine graph just keeps repeating. So it's going to do the same thing again. It's going to carry on going and do the exact same thing from 360 to 720. Okay, so let's get the first solutions in this bit that we can see, and then we can work out the next ones. So if I would like to know when sine of x is on this axis, is 0.6, I'm going to go to 0.6 on my y-axis. I'm going to go across. I should probably have made that less thick actually, shouldn't I? Let's do that. Let's go across at 0.6, and that happens in 2 places. It happens here and it happens here. So what is that x value? Well, we know that this is 90. So I've got here is 30, here is 60. And if 5 squares is worth 30, then each of those squares is going to be worth 6. So I'm going to say that this value here is 36 degrees. And I'm going to say that this value here is, what are we on here? 120, 150. So come back 6 from 150. It's going to be 144 degrees. Lovely. Okay, so there we go. We are that far in on each side. So I'm going to say the first 2 solutions are 36 degrees and 144 degrees. But we know there's going to be another 2 solutions here and here in the next wave of this graph. And that's just going to be 360 bigger because it's going to do the exact same thing again. So I'm going to add 360 to each of those. So that's going to be 396. And 144 add 360 gets me 504 for the other one. There we go. So those are your 4 solutions. The graph of y equals sine x is reflected in the x-axis. So if we reflect it in the x-axis, it's going to go like this instead. Write down the equation of the reflected graph. So that would be y equals minus sine x. Minus f of x reflects that way across the x-axis. F of minus x reflects this way across the y-axis. So putting the minus out the front, that is going to reflect it across the x-axis from up to down. Here's a graph of y equals f of x. On the grid, draw the graph of y equals f of x minus 2. Now anything inside the bracket affects the x direction, and it does the opposite of what you'd think normally. So f of x minus 2, anything inside the brackets does the opposite of what you'd think. So this actually goes right 2. So we're going to take this graph and we're going to move it 2 to the right. So this point here would go here, this point here would go here, this point here would go here, and moving each point is going to be lots easier than trying to move the graph as a whole. And then you can just join it up with a ruler. Don't do as I'm doing. And there we go. That's where your graph would need to go right to from there. Okay, question number 20. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there is a 70% chance it will rain in the village on Monday. Work out an estimate for the probability that it will rain in the village on Wednesday. You must show all your working. Okay, so we've got Monday here, rain or not rain. We've then got Tuesday, where it will either rain or not rain. Rain, not rain. And then we've got Wednesday. And it will either rain, not rain. Rain, not rain. Ooh, rain, not rain. And rain, not rain. There we go. And I'm interested in the probability of it raining on Wednesday, okay? So I'm particularly interested in here, 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 and here, those pathways. Now we know that the weather forecaster says there's a 70% chance it will rain in the village on Monday. So Monday, I've got 0.7 is the chance of rain, and 0.3 is the chance of no rain. And then, if it rains, the probability it will rain the next day is 0.8. So if we're coming up this rain pathway, I know that this one's going to be 0.8 and this one's going to be 0.2. And again, if it's rained here, this one's going to be 0.8 and this one's going to be 0.2. Same over here, because I've come up a rain pathway here, this one's going to be 0.8 and this one's going to be 0.2. Now, if it doesn't rain, the probability it will rain on the next day is 0.6. So if we come down a no rain pathway, I then want 0.6 and 0.4 to follow that. Again here, if I come down a no rain pathway, 0.6 and 0.4. And up here, I've come down a no rain pathway, so 0.6 and 0.4. Hopefully that makes some sense. I now just want to look at the pathways that end up with it raining on Wednesday. So I want this pathway, rain, rain, rain. I want rain, no rain, rain. I want no rain, 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 and I want no rain, no rain, rain. Those 4 branches that end in rain on Wednesday. And to get those answers, we're going to times along the branches and add the ones we want. So this is 0.7 times 0.8 times 0.8 for that pathway. This one is 0.7 times 0.2 times 0.6. This one is 0.3 times 0.6 times 0.8. And this one is 0.3 times 0.4 times 0.6. I'm then going to add all of those together to get my final answer. So 0.7 times 0.8 times 0.8, that top one is 0.448. And then I've got 0.7 times 0.2 times 0.6, that is 0.084. Then I've got 0.3 times 0.6 times 0.8, and that is 0.144. And last but not least, 0.3 times 0.4 times 0.6, and that is 0.072. I now just want to add all of those together. So 0.448, add 0.084, add 0.144, add 0.072, and again I'm going to do that on my calculator. 0.144, add 0.084, add 0.448. There we go. And that's all of them, and that gives me an answer of 0.748. Blimey, that is not looking good for the chance of rain, is it? There we go. So 0.748 for 4 marks. Very tricky, that one. That was probability, dependent probability, where it's changing depending on what's happening before. There we go. 0.748 is your final answer for that one. That is 4 marks. That is half a past paper. So hopefully you found that helpful. Let me know in the comments if you've got any questions, and I will see you guys next week for week 23.